Okay. So let's just talk about caching, and mainly we're going to talk about like session and I guess database caching would be the probably way to think about this. So caching, obviously, for common queries that are shared like across your users or workflows is obviously incredibly useful. Now, let me just say this. Am I sharing my screen? Good. Now, the benefits of caching, we've been doing caching for 20 or 30 years, so I don't think there's any kind of lost art to this. It reduces latency, improves application speed, can reduce like load on the back end, especially if there's a data store involved. And so you can experience large performance gains if you use caching and you have the right caching strategy. Now, write intensive applications are not going to see a great benefit to caching. It's usually read intensive applications where you can see large gains. So just to say this though, is that write intensive applications will have a greater read write capacity like ratio than 1. So recaching will still be beneficial if half the box is still doing reads and the reads are repeatable. Caching in front of that box could still be very useful, right? So now, when you're caching your data, there are a few things to consider. One, if there's data that takes a really long, slow, expensive query of any type to provide, and the results are reusable by other entities or other workflows, great data to cache. Static data that's frequently accessed, great to cache. Information that can be stale for a few seconds or a few minutes or a few hours or days, those are all great. Those are things that can be cached. For example, if you're doing 1,000 transactions a second, 80% of those are reads. Of those, 40%, like 50% of those 80%, like so half of it, 40% of the total reads, if they are all repeatable data that you can just present the same number or value to the user in question, caching is of tremendous benefit. If your data is 100% dynamic and it's an individual unique number for every workflow and every user, not a great idea. So stuff that's slow and expensive, stuff that has a complex, expensive data access pattern, or stale data that can sit there for a while, those are all great candidates for caching. Like WordPress, for example, is dynamically generated because it uses MySQL in the back end. But once a blog is posted, the blog is static. Only the comments are typically dynamic, right? So it looks like that would be dynamic content, but it's not. It's static content. The article itself isn't going to change. This is where technologies like Elasticache, but also things like CloudFront, which do caching as well. This is where these come into play. So Elasticache comes in 2 flavors, which is either memcached or Redis. We've talked about this before. There's also, by the way, memcache, like managed Redis that they have as well. So what this does is that this cache sits as an adjunct, has an add-on above the data store. And what will happen is that you will write items, either load them, through another separate process, or as you write items to the back end, you're going to write items to cache. Just depends on your caching strategy that you want to follow. And what will happen is that apps are going to go check the cache before they check the database. Typically, an in-memory data cache like Elasticache is going to feed out items faster than having to scan or query a table. And again, you have to architect that. Now, memcache and Redis, and by the way, this shows up on the exam, have very different kind of capabilities. Memcache will multi-thread, is much simpler to use, and with auto discovery in particular, will scale horizontally, but it's typically only going to function inside of a single availability zone. So this is where you have like your databases maybe in separate availability zones, or you have read-only copies in separate availability zones. And so you just want a single cache that can be just accessed locally by that availability zone. You don't need replication between the caches. Redis, on the other hand, by the way, supports complex data structures, does pub sub, will do read replicas, will do clusters, will do all kinds of multi-AZ enablement. So very different possibilities here. Adam, what's an atomic operation? You know, that's actually a good question. I'm not sure what they mean by that. Atomicity in general refers to like how databases can be acidic. And so I'm not exactly sure how they're using atomic operations here. Actually, let's look that up because I am actually confused about how they're using it. I'm assuming they're referring to it in a database context, like acidity. Let's see what it says here. Either all the commands are none or processed, so on a Redis transaction is atomic. Okay, that makes sense because that's the way it works in a database. In other words, what happens is that when you're executing a command against the system and it makes it like, let's say 3 changes, either all the changes are done or none of the changes are done, right? So if you're like running some kind of change, all of them have to execute or none of them are successful, right? That's what they usually refer to with atomicity. That's part of it, the acidic set when it comes to databases. So is acidity, which usually refers to atomicity, consistency, right? Isolation and durability. So that's just a database concept. Do note, by the way, that they are going to ask you questions on the exam, like you need multi-threaded performance for your cache. You're going to choose Memcache for that. They're going to say things like you need to put 3.2, like, terabytes of data into a system. That's most likely going to be Redis, right? That's as of version 3.2. They're going to say things like we need pub/sub messaging or advanced data sorting. Guess what? That's Redis. And let me just simplify this for you. Pretty much any question they're going to ask, if it doesn't relate to multi-threading or horizontal scaling, it's going to be Redis. If it relates to multi-threading or horizontal scalability, then it's going to most likely be Elasticache as the answer. Anything else as far as advanced data types, data persistence, they're not going to ask you about atomicity, right? Read replicas, failovers, setting up clusters, doing cluster modes, right? That's all going to be Redis because Redis is the only one that does that level of complex setup. Data types such as geospatial indexes, bitmaps, all those complex data types are all going to be Redis as well. So really, you need a simple cache with multi-threading or horizontal scalability. The answer is Redis. I'm sorry, the answer is Memcache. Otherwise, every other answer is going to be Redis. Yeah, just to say this, Memcache, by the way, is pretty much designed to cache flat strings like HTML pages, serialized JSON, that kind of thing. Redis was designed for so much more. Here's a quick kind of yes, no chart, right? So you can see the capabilities in contrast. So again, simple, horizontal scaling, multi-threaded, it's going to be memcached. Everything else, Redis. Other things to know is that when a node, which is basically almost like an EC2 instance that you can't see, because remember, this is a managed service, right? It's the smallest building block in an Elasticache deployment. It's a fixed, like a node is like a fixed size chunk in a sense of like network attached secure RAM. So each node has a size to it. When you put a bunch of nodes into a cluster, that denotes the amount of memory that the cluster like can handle, right? So you put node caches in there, they are clustered together into a cluster. You can also create replication groups, like where you have 2 clusters replicating to each other. A replication group is just a collection of Redis clusters. Typically, if you have multiple Redis clusters, one is the primary read-write cluster, and the other up to 5 secondary clusters are read-only clusters, right? Those are read replicas. So you get a primary read-write cluster, and then you got read replicas. Each read replica, by the way, if you have like 5 of them, is going to maintain a copy of the data from the primary cluster. This is eventual consistency. It is asynchronous. So applications can read from any cluster in the group, but writes can only be made to the read-write cluster. So an endpoint, by the way, is the unique address that you used to connect to the cluster. So do note that, by the way, if you have a cluster that has a primary read-write cluster and you have like 5 read replica clusters, You're going to have an endpoint that connects to the primary cluster that's used for writes, and you're going to have a read endpoint that connects to a specific cluster in the replication group. So it's going to rotate around. So otherwise, you're just going to have one endpoint that's going to point to your primary cluster. That's it. So just know, the thing you have to remember that sometimes pops on the exam is that when you have a Redis set of clusters, like a replication group, you're going to have a read-write endpoint and you're going to have a read endpoint. That's the main thing you need to remember. They're not going to ask you about sizes or anything else, so don't worry about that. Oh, this one basically, this particular slide talks about how do you load your cache and how do you like manage staleness of the cache so that you like make most things a cache hit versus a cache miss. Because usually if you miss the cache, then you have to take extra steps to populate the cache, which means that the client transaction is going to be slightly slower. It may still be within your business requirements, so that's not necessarily a problem, but we prefer cache hits over cache misses. So what is the strategy that we use to populate this cache to make sure it's super like accurate? Well, there's a couple of different options here. One is lazy loading. The lazy loading is efficient because it only puts data into the cache that's actually been requested by a user. So you don't actually like stack the Elasticache, for example, instance with all of the data from the database. The only problem with this is that the first user who hits that requested data and they miss the cache, they will pay a performance penalty of having to go back to the database, feed the data back, and then copy the data into cache. This is also fine because if a node fails within the cluster, which by the way isn't a problem because everything's replicated, but if a single node fails, you're going to lose all your data, which means you have to start over and the application is going to have to populate it as it runs. This is called lazy loading, meaning a write to the cache only happens when the cache has been missed. Now, the other way, which is less efficient from a storage standpoint, but more efficient from a performance standpoint, is every time you write an update to the database, you just go ahead and update the cache, whether it's being read or not. So there's a write penalty here because the application has to make two trips. It's got to write it to the database and it's got to write it to the cache, but reads are going to perform excellently because every time you go to hit that cache, that data is most likely going to be there. Why? Because every time you write to the database, you're writing to the cache. Now, there's one thing missing here is that you might need to pre-populate the cache when you first, especially when you first launch, or if there's like a reboot or something, with all the data from the database. So there is kind of a secondary consideration of like, how do we set a baseline of data on the cache? You might need to like take all the values that you think are significant and pre-populate them on the cache. I will tell you that most people don't do either just pure write through or pure lazy loading. They identify the top 30 queries, top 50 queries that are running against their database, and they throw that into cache. And then they usually do write through at that point in time, which means that it only gets updated when it gets updated by the database. Sometimes the application that does the updates against the database is not the application that's taking care of the client. Meaning what will happen is the database might trigger like a stored procedure or something every time it's updated to populate data into cache. Or there's another application that's watching the database and it sees that as data has changed, it goes and populates the cache for you. So there's other mechanisms other than write through and lazy loading to manage caching, but these are the general kind of strategies. Do we write data to the cache when data is missed after we've gone to the cache, or do we preload the cache by writing every single write to the cache? Most people are somewhere in between those. Any questions about the advantages of like the difference between lazy loading and write through? Okay. Consider caching when data is accessed infrequently. Is that a true statement or a false statement? Is that something we want to chase if data is cached infrequently, or is that not true? Yeah, in general, right? If data is not being accessed frequently, we probably don't want to cache it. Oops. Wow, just kind of kept going there. Hold on. So memcached offers multi-threading where Redis is used as single threading. Is that true or false? Yeah, so memcache is the one, right? I know you probably just saw the answer, but still, just in case. All right, only Redis provides multi-AZ with auto failover capability. Remember that for whatever reason, memcache is typically associated with a single availability zone. It doesn't necessarily have multi-AZ with failover capability. So that's true. TTL, which relates to staleness, is an integer value that specifies the number of seconds until a caching key expires. Is that true or false? It's true, actually. Right? That relates to the number of seconds until data expires out of a cache. In other words, you might want to force the cache to drop data that you know is stale, right? Because it's time-based data or stock trading or weather or something like that. And you might say, look, I need you to expire this every hour. Because if this data is still here after an hour, it's no longer valid. So just drop it. Okay. Next question. The write-through strategy adds data or updates data in the cache whenever data is written to the database. Is that true or false? That's true. See a bunch of them true. That's good. All right. Last but not least, memcached includes pub sub capability, advanced data sorting, and clustering. No. You're like, no. Forrester, you just added a bunch of stuff there. There's no way. Good. All right. That's it. That's the simple little set around clustering. Anybody have any questions about any of this? You do have to instrument this in code, by the way. So much like having a reader database versus a writer database versus a cache, you do have to instrument the logic in this with code. There's plenty of great libraries to navigate this, but just know. Okay, we're gonna end. Oh, we might actually get through this. We're gonna talk about developing secure applications, which is just gonna highlight a few things about AppSec that you need to be aware of. Remember, security was a good portion of the exam, so think of this as a primer towards that end. So securing, authenticating your customers, a little bit of a core scenario, a little bit of a wrap up. Okay, so here's one challenge is that when we want to secure data in transit, not data at rest, there's always a challenge when running your own public key infrastructure or even integrating with a third party. It's always a challenge. Certificates expire. How many of you have worked on a website and the certificate expired for the website, and the next thing you know, people are getting those dumb Chrome pop-ups or Firefox pop-ups say, hey, by the way, part of this is SSL, part of this isn't, we don't know what's going on. Are you sure you want to go forward? Because we don't really know where this is coming from, right? It may not have happened in a while, but it has happened, right? Now, this is where things like ACM, which is the AWS Certificate Manager, this is like a tool that you can use to literally just request certificate renewal. And by the way, if there's a load balancer that's terminating the certificate, AWS will rotate it automatically. But you can just request things, right, from the certificate manager. to publish, manage, provision, etc., TLS and SSL certificates. So you can request a certificate, deploy it on like any of the ACM integrated resources. This could be CloudFront, API Gateway, the Elastic Load Balancer. You can also import third-party certificates as well. You can also create private certificates. It just allows you to manage the certificate lifestyle centrally. Public and private certificates, by the way, provisioned through ACM for use with like load balancers, they're free. They don't cost you anything. For private certificates, by the way, you do actually have to pay a little bit of a fee for the operation of the private CA and for the private certificates that you issue that are not necessarily coming through the ACM per se. But if the ACM, by the way, has to host its own private certificate authority, there's a little bit of a fee for that. So the certificates themselves are free, but the certificate authority is not free. So just make sure I'm clear on that. Make it sound like it's all free. So that would be about basically data in transit, like how are we going to secure our websites? How are we going to secure like mutual TLS and that kind of thing between our applications? That's ACM, the certificate manager. Now, the other challenge that we have, other than securing data in transit, is that we can't be sticking database username and passwords inside of our credential files. We really honestly don't really want to, stick them in as environment variables even. If possible, we would like to kind of grab them from what we call a vault, meaning the application boots, it knows it doesn't have the password, so it makes an API call to a vault and says, hey, can you give me the username and password? Here's who I am. The application has permissions to grab that secret. And what that does is that a secrets manager, as an example, will basically rotate those credentials for you and will provide the database username and password based on permissions for the application, and nobody needs to see it. The application can boot, ask for it, and the only person who's ever seen that password is the person who stuck it in the vault. Separation of concerns, right? That way, by the way, if the person or automation process updates the database password, it can update it in the secrets manager, which then will allow the application, let's say the application goes to access the database and it's like, oh wait, I'm getting incorrect password. Let me call the function to get a refresh password. So this is great because quite frankly, you think you want to log into the database, but you don't want one when you're in the middle of security audit, when all of a sudden you're being asked to, hey, we saw that your login, which was shared with 15 other people, was also used to, we don't want to be part of those conversations. So secrets manager is a way to do this. Now I don't want you to be fooled. Amazon also has another product called parameter store, right? It's part of systems manager. It will also store what they call secure strings. You just have to set the string to secure. But I want to be super clear about this. Secrets manager is the only one that will actually expire and rotate credentials. The parameter store will just store a string, a secure string. That's it. Secrets manager will actually rotate credentials like API keys and database credentials and other secrets throughout a life cycle. And they will can actually trigger an update against the application. So secrets manager is a much more robust secrets management system than say like the systems manager parameter store, which is another option. By the way, this could be OAuth tokens, right? It could be a lot. Here's how this works. No human being ever really touches the secret or sees it in plain text. The only person who's ever seen the password in this case would be whoever stuck it in the secrets manager. In this case, let's say you got an EC2 instance or a container or a Lambda function, and it has access via a role to talk to the secrets manager for that particular secret, not other secrets, that secret. The secret is returned back to the code, and then it uses the username and password as an example to connect, or the certificate, could be a certificate for that matter, to connect to the database. Let's see, Billy, is there still integration with Active Directory? Do you need to be concerned with single sign-on for the exam? I have to look at the exam guide for that. I don't think single sign-on is on the exam. There is still integration with Active Directory. Single sign-on is also a separate product that can obviously be integrated with Active Directory. I think single sign-on is on the SysOps exam. I don't think it's on the developer exam, but I would have to look at the exam guide. So we'll take a look. Billy, ask me again when we get to the exam cram. Or I'll remember. I probably remember. So with this, by the way, the secrets manager, just remember that you have to have permissions to access the secret. But when the app boots, if it has permissions, it can just talk to the secrets manager, grab the password, use it for all of its authentication. Again, reminder that there is another product that's not called Secrets Manager. It's called Systems Manager Parameter Store. Parameter Store is the name you probably need to remember, but it won't do rotation and all this other stuff. It just will literally hold a string. And the ACM, the AWS Certificate Manager, is the one that will do certificate management for SSL and TLS certificates. So two different products that we just talked about: Certificate Manager and Secrets Manager. Okay, so let's talk about authenticating your applications with AWS. First of all, most of us are used to using a user, like a service account, almost like an access key and secret access key. We don't really want to do that anymore, right? You can either use the secure token service to like request a temporary ID, which, by the way, will give you a role. Ooh, thumb was all jammed up. And the secure token service, by the way, is one of Amazon's oldest services, but it's iterated upon a lot. But it's pretty much what everybody uses when you federate with something else, is that a token is passed via STS. Now, STS basically provides a federated users with access. You can configure the expiration, the lifetime of the credential in question. You can use IAM policies to control who does and does not have access. There's no limit. It will give you 1 million credentials if you want to. By default, and this is something you need to remember for the exam, a token has a lifetime of 3,600 seconds. It's an hour. After they expire, they cannot be reused. So just know 3,600 seconds for a token from STS. You can also, by the way, do MFA against a token if you want to. To support SSO, just to mention this, is that the endpoint is going to return a token that it can use to construct a URL that will sign the user directly into the console without using a password. So STS is at play when you use Active Directory or another identity broker. Here's an example, by the way. So what happens is, in a corporate data center, you have to federate with whatever broker you have first, and that broker has a trust relationship with AWS. When you log in to, let's say, Active Directory or Ping Federated or Okta or whatever, and you authenticate with that, then it will go over to AWS, verify that this person is who they say they are, and then it will give you an authorization token from STS. Those temporary credentials that can then be used to access services. So STS has a few caveats. The secure token service has a few caveats. All calls go to the global endpoint by default, which is actually located in North Virginia. Regional endpoints are activated by default if you call them, like you have to call them, but by default, it's going to go to the global endpoint in North Virginia. If you want to see all the information about the API calls you're making against the account, against SCS, you got to look at CloudTrail. But just be aware that these credentials, just like IAM, these are global, meaning they're going to work wherever your account exists, which is globally, right? So the reason I mentioned the global endpoint is that it's probably a good idea to make calls to your local regional STS endpoint instead of going to the global endpoint. So I would say this, by the way, is that you can actually start with the regional endpoint and then fall back to the global. So you could put, logic in your application to do that if you want to. I just want to mention this. I know this slide says this. If you go to call a regional endpoint, let's say you go to call STS inside of US West 2 and it doesn't seem to be working. I know this is a little bit counterintuitive from what the slide just said. You need to log into your account and click on STS and make sure that STS is activated. I don't know why, like this is a little bit different from what the slide says, but I know it says that the regional endpoints are activated by default. That has not been my experience actually. So just know that if you're trying to like get a token from like California and it just is not working, just go into STS in California, just make sure that it's active, right? Because I don't know, and it'll throw an error message saying it's not active. I just want to mention that because my experience has varied recently on that. Here's a picture for the identity broker scenario I was talking about before. Here, the user is going to log into Ping Federated or Okta or Active Directory. It doesn't even matter what the broker is, right? But it's basically a corporate identity store. That's what it is. And by the way, they're going to ask you questions about this process. So I'm going to say it again, just so you can hear me very clearly. The first thing you do anytime you want to log into AWS using another product like Okta or Ping Federated or Google or Active Directory is you authenticate with the external third party first. You log into them first. Then what happens is that once the user is authenticated, then the broker is going to go get credentials from STS for you. And then it's going to return it back to the console and redirect you into the services in question. So you can access the APIs. So I just want to make sure that steps are very clear. You log into the broker in the corporate identity store first, then you access STS to get your credentials. Those credentials are returned, and then you can access the console or the API or whatever you're doing. I don't know why, but they ask you questions like this to say, they'll be like, you authenticate after you grab the token. They're going to challenge your knowledge of the order of how this works. Why? I have no idea. They just do every single time. So remember, log in first to your local store, get your credentials, return the credentials, go access your services. You might say, well, Michael, how does AWS know it's okay to give the identity store permission? Just so you know, under IAM, you can actually add identity stores as long as they're SAML and OAuth compliant. They'll exchange metadata, and then what will happen is that you now have basically federated your IAM account with, you federated it with the store in question. Okay. You can also, by the way, give the store credentials if you want it to just have access to STS without doing some kind of trust relationship. All right, so that's via the token service. You can also do identity federation, which is literally just what I was talking about. So you don't have to just actually like call the service. With identity federation, it's the same thing. As long as they support SAML and OpenID, what can happen is that you just give them permission. So that process that we just looked at works the same, whether you're calling STS directly, whether you are federated, right? So you're not making an API call per se. You're just federated between the two identity brokers and between IAM, in this case, STS. So it's going to be the same. It still has to support SAML. It still has to support OpenID, OIDC. SAML 2.0, I think, is the required version. You do have to, map roles to like groups and users inside of your identity store, right? So just because someone has federated with IAM doesn't mean IAM is going to give anybody permissions. You have to tell IAM that these users take on this role. This group takes on this role, right? Just because you federate them doesn't mean this stuff just happens. No, Amazon doesn't do that by default. By default, everything's locked down, right? So especially if it's a well-known provider like Amazon, Facebook, or Google, you have to give permissions for that resource to get access to your account. So make sure that's clear. Let's see, the security assertion markup language 2.0. It's an open standard for exchanging identity and security information between applications and service providers. So SAML, enabled applications are going to delegate authentication requests to your like corporate directory, as an example. So this will allow you to use single sign-on to sign into all of your SAML enabled applications. Federation, basically, first of all, the user logs first into their portal or their data store. This is not any different than what we just looked at using STS. You have to log into your data store first. Then the SAML assertion comes back and says, yep, I know this user is who they say they are. You post the SAML assertion to AWS, which says, oh, I know, I trust that entity. I'm going to return you some credentials, and then I'm going to allow you to get to the management console. Remember, you have to have a trust relationship here for federated identities to work. Federation is any identity store that you want to hook in. It could, like I said, Active Directory, any of the known products, ForgeRock, Okta, Ping Federated, that kind of thing. Oh, Cognito. How could I forget Cognito? This is Amazon's core base service for this, right? So this Cognito is basically an authentication service, authorization service even, for mobile user data and web data, right? So you don't have to have any backend or managing infrastructure. So this says mobile identity management and data synchronization across devices. So you can save data locally on somebody's devices so that it can work even when the user is offline, like they're not connected because they're on a mobile device. It just simplifies the way that you can log in and manage data for these platforms. So it even says it here. It does support public login providers, like if you want somebody to log in using Google, for example. It can also be your own independent. It will allow anonymous/guest access. It has an example, just to follow this. Device logs into whatever log provider, let's say it's Twitter or Facebook or whatever. What happens is then that's going to return, right, some kind of token/authentication information back to the device. It's then going to submit that back to Cognito, who's going to say, oh, I recognize this device in this relationship and this provider. I support that. Let me go validate your information against the provider that you said that you logged into. You know what? I validated it. It looks good. I'm going to send that back and say, you know what? You are who you say you are. And then what's happening is that the device is then going to send out an API call and say, hey, Cognito, now that you know who I am and you've given me validation, can you give me some credentials because I need to access some services on the back end? Cognito is going to validate that request once again, and then it's going to send something to STS and say, hey, can you send this back to the device? Send it back to Cognito and then send it back to the device. And then at that point, using those credentials that it got from STS, it's going to go access the services. Notice there's this whole chain of things that's happening. But the first thing that happens is that you have to log in to your federated identity provider. Then you talk to Cognito, who then talks to STS, who then basically gives you the credentials you need to access the services. Now, in this particular case, let's say that there are some developers who want to use their own identities instead of using a public identity provider. Cognito makes this easy to accomplish this because you can basically use Cognito as an identity broker. So in this case, let's say there's like a user authentication system or whatnot that the developers are using to kind of like create their own user store. That's going to do an assertion against the identity broker, which is, again, there needs to be a trust relationship here. Cognito is going to say, oh yeah, okay, great. Yeah, I recognize that system. Here's the token for your stuff. That gets passed to the user, which then is reasserted back to Cognito now that the user has it in their possession. They will pass the credentials, the actual Amazon credentials, back to the user. You might say, Michael, why don't they just pass the credentials back in the first step? Because then the credentials would actually be in the authentication system, which is not what they want to do. They want to give the authentication credentials only to the user who's going to use them. Once the user has the credentials, then they can access the services in question. Because you might be looking at this and going, Michael, why are there like 2 or 3 steps to this process? Remember, these systems only want to give security information to the user who's going to use them. They're not going to give it to the authentication system or other intermediary systems. They're not going to do that. You might say, Michael, why is there a validation of all this? Like validation of the tokens. They already validated it once. Why would they validate it again? Because it's a security process. They have to. So this is where Cognito can federate with just any kind of external authentication system to grant authorization, right? Because remember, authentication is who are you? Authorization says, what can you do? Other things to consider when authenticating your customers is that, there is a user directory inside Cognito that will allow you to support all this stuff that we're talking about. Social sign-in, user directory management, MFA, password policies, phone and email verification, custom, like all this stuff. So just know that Cognito will support by itself all of the identity broker, identity store stuff. That's the technical term, stuff. Notice that apps can just authenticate and get tokens, and then they can get a social sign-in, and then that will allow them to get access into AWS resources. So this diagram is a little kludgy from my perspective. Hold on. Just draw this out. All right, we've got an app and a user is directed to authenticate. So what happens is they're going to go to some kind of like UI that Cognito has. What's going to happen is that they're going to determine who is the identity provider for this particular user pool, this user identity. And what's going to happen is that it's then going to basically go talk to the IDP, which is going to authenticate the session and then post back a SAML assertion back to Cognito. Cognito is going to update the profile, and then it's going to provide tokens to the application, verifying that this user now has these permissions. So notice that workflow there is it talked to Cognito. Cognito went to talk to the identity provider, got verification, came back to itself, and then gave a token to the application based on the user's authentication request. Same process that we've seen 3 or 4 times now. I know you came to me to log in, but I got to talk to your identity provider because this is who provides the authentication information. I get that information back. Then I can give you access once you've authenticated with your identity provider. We've seen this 3 or 4 times now. Questions? Let me ask you a question. If I have an identity provider in play in my login process, and I've got Amazon in play, I've got STS, Cognito, doesn't matter. What is the first thing the user must do before I can give them a security token? Give me the A word that they need to do first.
Authenticate with their own.
Exactly. Exactly. That's exactly right. I need you to authenticate before I'm going to give you authorization. Okay, so they're going to authenticate with their provider first. You are going to get asked questions on this, at least one. I just want to make sure you get it. Other questions? Because I think we're at the end, other than me drawing random green arrows on the screen.
What's going on in this case when you see something like you're signing into a system that says use Google to sign in or use Facebook to sign in, or et cetera, et cetera. So you're logging onto somebody else's system, but you can use a Google sign-on to do that.
Yeah, so in that case, what they've done is they've basically said, let's back up for a second. So it's this scenario right here. What happens is that someone has said that we will allow Google to be the identity provider for Cognito, as an example, right? And so what they've said is it's okay for you to accept logins if Google will validate that the login is real. Because in some cases, people aren't necessarily trying to restrict security permissions. What they're trying to do is they're just trying to track and create a profile for the user. In other words, if you're willing to accept any authenticated user, as long as it's a Google authenticated user or a Facebook authenticated user, you're just trying to verify that the user has a legitimate login, right? Then you'll take the login provider. And so what will happen in this case is that you've told Cognito, I will take logins from Google. I will take logins from Facebook. So a trust relationship has been established. That's called Web Identity Federation, WIF, right? And what you're saying is that as long as they have a valid Google Facebook login, I'll take them. Same process applies though. You have to log into the identity provider first, and then Cognito will give you authorization information. But just know ahead of time that someone has said to the Cognito or whoever the identity like authorizer is, they've said, you know what, we'll take Google authentication, we'll take Facebook authentication, and we will authorize that if it comes from those sources. So someone has set up a relationship there. So don't be fooled. All of this does require someone to have set up a relationship to say, this is okay. Without that, you can't just take it from anybody. Does that help, Joe?
Yeah. So basically, when you click on that button to use Google login, you're actually logging into the Google box first, and then the Google send you that information across.
Yeah, exactly. Funny story. I actually had to sign up for Cahoots. I don't know if you've ever used Cahoots. It's like a fun gamification system that we use frequently for stuff. And I realized I didn't have a login on it. I've been using other people's Cahoots. I haven't been using my own. So I went to go create it, and it said, hey, do you want to create it using Facebook? You know, was it Facebook, Google, Clever? I don't even know what Clever is. And I should, but I don't know what Clever is. And so I was like, I just chose Google because I'm already logged into Google. And so it popped up a Google dialog and said, hey, do you want to use itamazonian@gmail.com? I was like, yeah, that sounds great. Let's do it. And then it just created my login. So Cahoots allowed me to log into Google and then gave me authorization access to their website because I authenticated with Google first. No difference here. But somebody set that up on Cahoots side.
Okay.
Okay. Woo. All right. So let's talk about a scenario here for a second. In our scenario, notice that we have website hosting, we have an API gateway. You may remember that API gateways can authenticate with Cognito. Really, any authorizer, but here they are, they're authenticating and authorizing with Cognito in this particular case. So we have to give obviously Lambda permissions to authenticate and check and execute. We have to give the API gateway permissions, obviously. We have to set up some kind of relationship here. So just know that as part of your kind of like end-to-end kind of last lab that we're going to do, you will have you will basically set some of this up. Because you've actually done most of this already, right? S3 buckets, API gateway, Lambda functions. Okay. True or false? You can download the private key generated by Certificate Manager. By the way, I didn't talk about that at all. So if you know this, then you know it because you knew it before. I didn't mention this in any way, shape, or form. Just so we're clear, because I didn't share this, it's false. You actually can't download the private key. You can download the public key all you want to, but you can't download the private key that is generated by Certificate Manager. The public key is meant to be shared. The private key is kept by the Certificate Manager for obvious reasons. It's private. It's for management of the certificate. You can, by the way, associate that private key with obviously the devices that need it, such as the load balancers and whatnot, so they can obviously do what they need to do. Next question. STS temporary security credentials can be reused after expiration. Is that true or false? Can you reuse expired security tokens, expired security credentials? Exactly. That answer is false. Why even have them if you can reuse them? You like reactivate them? No, just get a new one. Question for you. STS security credentials have a by default lifetime of what? How long by default are STS tokens valid for? Good. 1 hour, 3,600 seconds. Just want to make sure I said that. Next question. Secrets Manager can rotate your database credentials. Is that true or false? I hope I made a big enough deal out of that. Parameter Store cannot rotate your credentials. Secrets Manager can. They are going to try and catch you by saying that you can use, they're going to say you need something that's going to do this, and then rotate credentials. And in the answers, they're going to show you the exact same answer with Secrets Manager and the exact same answer with Systems Manager Parameter Store. But the requirement says you can rotate credentials, which means it has to be Secrets Manager. Can't be Parameter Store. So the answer to that is true. Last two. Amazon Cognito federated identities can be used to store username and passwords for your customers. If you are federating with another data store, is Cognito storing your username and passwords? Is that true or false? That's right. If you're using somebody else to authenticate, they have the username and passwords. If you're using somebody else to authenticate, they have the username and passwords. You don't have them. So if you federate with somebody, you are giving the data store over to somebody else. That's not you. Now, if you're not federating with somebody and you're using user pools inside of Cognito, you are storing the username and password, but that's not what they said here. They said federated identities. That means you are federated or connected with an external provider. Man, this is a biased question. SAML and OpenID Connect is more complicated to implement than STS. Is that true or false? What do you think Amazon wants you to say to that? Which is better, the industry standard or us? Come on, you know the right answer. You know what they want you to say here. Some of you are putting false, right? It is false, right? This is false. SAML and OpenID is like, it's not true that it's more complicated to implement than Amazon, the AWS STS, right? I'm not sure what they're trying to get to with that question. I mean, honestly, I would argue that STS is easier to use, but I'm not sure where they're headed with that question. Okay, questions of any type around any of the like securing your applications, authenticating mechanisms, authenticating your users, federating identities, using data stores, Cognito, any of that.
Do the questions around the security get more detailed than this?
They do, but most of them are going to be covered in the paper on securing your applications. So, but like, they're not like numerically more detailed. It's like questions, Gerald, like, don't put your database credentials inside of a Git repo, or, if you wanted to secure communications between two applications, what would you turn on? And it will say like data at rest, TLS SSL versus like data disk encryption. It'll do like questions like that. So it won't get much deeper than that. It's not going to ask you like really deep AppSec questions. That's about the level that they're going to ask you questions at for AppSec. They're not trying to solve any industry standards there. They just want you to know what services in AWS you have to use for security. Okay, so time-wise, we're pretty good. I do want to mention that we are going to talk about deploying, which is a relatively short slide deck. And then I will actually do the course wrap up before we do the lab, just because I want you to have the option when you're done with the lab to just be done, right? Don't worry, I'm gonna stay with you the entire time for those of you sticking around. No one's abandoning anybody, right? But I'm gonna end up the course wrap up. And then note that when you get back, the first thing we're gonna do is we're actually not gonna talk about deploying applications. I'm gonna talk about the last kind of little part, and we're going to run through some practice questions for, your developer exam. So I'm going to run through just the last little piece, make sure there's no lingering questions, run through some practice exam questions like we did yesterday, which was kind of fun. And then, we'll move back into content at that point, and then we'll end the day with the lab. Okay. Questions about what we're doing from this point forward? Okay. So let's do this. Is that I actually have to go do something with my son, who, by the way, is not concussed. He just he has some bruises on him. I'm gonna do something for my son. I'm gonna be back at 1:05. So let's just go a little bit 5 minutes over. So you got 65 minutes. I'll put a timer up, and then I will see you all at 65 minutes. We'll start at 1:05, and that will be the rest of the day. All right, we'll see you in a bit.